year. That's the banking, finance and sustainability, cross-culture management, cyber intelligence and security, supervised research activities, which was almost 3 hours, 300 hours. English language C1, which was compulsory and individual learning too. And in the summer school, which are the most rewarding activities which I did, that was on this second doctoral summer school, which I had in Pastor. That was the date was 10 to 14 of June 2024. Now, the topic which I was looking in this whole year, I was getting deepfake audio using null spectrogram and XAI. I was mostly working on the null spectrogram on the audio side, and the second portion was the XAI, which is explainable artificial intelligence. So why? Because developing innovative techniques for audio deepfakes detection utilizing advanced deep learning architecture, applying what XAI. XAI means what explainable artificial technical techniques over here. So in these techniques which I'm going to use, which is the GrandCam for the audio analysis. So in a deepfake, which is with the audio deepfake, which is the product of artificial intelligence used to create convincing speech sentences that sounds like specific people saying things which they did not say. Audio deepfake involves the generation of fake speech, often using a real person's voice to say something they never did. Detecting these manipulations is critical for security, protecting privacy, and preventing misinformation. Examples of audio deepfakes including fake phone calls, voice impersonations, scams, or generating fraudulent audio recording. So why null spectrogram? Because there is some specific reason. Because I use besides null spectrogram, I use MFCC and other feature extraction techniques. But I found null spectrogram is more important. Why? Because in null spectrogram we can precisely help with the human with the different pitch of the audio. And the second thing, analyze the null spectrogram, identify the pattern and anomalies that indicates artificial intelligence in audio content. So for the audio contents, and the second portion was for the human perspective on the different pitches. So we can easily detect the ways fake or real problem is. So in this problem, so we work in the defect audio detection. The most important thing is the null spectrograms images which I took, which is 224 cross 224, right? In the data set which I was using was a fake AV cell, and in this data set which was consists of Asians, different cultures, plus male and female, both of the voices. So over here you can see on the side, so you can see the fake and audio, the real and fake, the difference of these null spectrograms. So over here, this is a general framework which I worked the whole year, which I was working in. On the second portion was important, because in the first portion last year which I was working on null spectrogram and resizing. This year mostly I was focusing on the audio augmentations and binary image classification and classification matrix and XAI, which is the GrandCam visualizations. So over here, this is the processing steps which I used it, the same thing which I explained. So over here to explain to perform different on this model experiments which I did. This experiment, this is generally 21K, this is the size of the images, and plus this experiment 1, 2, 3, 4. These are different for experiments. These are the preliminary results which I worked on it with the different using CNN models over here. And plus with these results over here, this is the splitting of the data set, which is on the one side you can see the real one, on the other side is the training, which is one is the training, another is the testing one. The training one, which is present in the audio data augmentations portion. The data augmentation portion which I was working in was in my 3 types of augmentations was working on. In my voice noise, Gaussian noise, frequency and time masking. The third figure which is showing over here, this is showing the track, which is the frequency and time frequency. This is mostly the spectrogram. This especially this technique which is working on the frequency and time masking. This is especially for the augmentation side. So this is these two representing my audio. This is audio augmentations. So I will apply all of this. The result after predicting from the results, this is my predicting results which I was getting out. The results was very good. After that, the most important thing is the our grand camp class accreditation, which is explainable. So for this thing, I almost get the heat map with this model. Obviously, all these my models have their own they have their own camp, right? So over here, when I have to get this thing for the grand camp class accreditation visualization, so I have to change their properties. After that, I have to apply on this whatever the prediction result is. They give me the heat map. In this heat map, this is the novelty of this project is. So the work of this because I work deeply on this type of things, because this will represent the fake and real portion, and which is the on where there is a more heat. There's a audio signals which you see the more audio signals in it. So that portion visualized. Other person didn't visualize. So this is the difference between the fake and the real portion. So this is the which I've been working with here on this project, and all this is going to be, sooner or later we're going to work for the conference, and that's all from my side. Thank you very much for